Closed. All right. So the deal is as follows. We are going to continue with current unit with the introduction of loops. And once this loads up, there we go. So this is the second chapter from the unit. And as just like before, the first lesson of each of these chapters is sort of an introduction situation. And same thing with the second one, where the third one we actually get into practice. We're going to do 1 and 2 today, and I'm all over the place in lists. Maybe I should have a little wider perspective. There we go. Okay, so loops, the second of the 3 chapters from the unit. And yeah, there we go. We've talked about it briefly if you were in my class last semester when we did the Under the Sea scene, which I don't think students with different teachers had that, which is fine. But regardless, the unit is going to start with a couple video or one video. Said it last time where it was like one video broken up into 4, 90-second videos. At least it's only one this time. If you are watching this on replay, we're not gonna see it, or it might look weird. The video is this video right here on the spreadsheet for the day's activity. And apparently we have innovation today. Feels like we have it every day. Okay, so we're gonna have the video only up on the front. And let's go like that. And we'll do this with that. And we'll go like that. And it's going to work. Please work. All right, here we go. Loops. This is starting. Go ahead and turn around. Let's go and do laptops close. Turn around. Here we go. This is happening. Get comfortable. Fantastic.
Windows Devices Group at Microsoft. It's basically a team where we build cool stuff, tablets, phones, things like HoloLens that hopefully will excite and delight customers. Computers are not infinitely fast. They are much faster than human beings at many tasks. In 2014, the fastest computer in the world was clocked in at an astounding 33 quadrillion calculations per second. Now, for some tasks like composing a song, we generally think human beings still do a better job. For highly repetitive tasks that can be automated, computers are much, much better. Programming languages usually have a few different ways to define and control behavior that should repeat. These are usually called loops. They go by different names in different languages like for loop, while loop, do while loop, for each loop, repeat loop, and so on and so forth. These types of loops have small differences, but all of them are just different ways to get the computer to execute some lines of code repeatedly. The generic term for looping is iteration. Iteration is just a fancy word that means repeat. It usually is in reference to the repetition of a process or a procedure. This is why iteration is a good generic term. Often in programming, we have an algorithm that just needs to repeat a specific number of times, or repeated while some condition holds true. We're going to show you how to use a looping structure called a for loop in JavaScript. You can find for loops in the control section of the toolbox. It looks like this when you drag it out. A for loop in JavaScript, like this one, is just a type of counter loop. It counts up from 0 to the number you type in. Why does this simple for loop look so complicated? JavaScript, unlike some languages, doesn't provide a simple repeat loop structure. The for loop is a very powerful and versatile looping structure for both advanced and simple tasks. We're just keeping it simple for now. Let's do a little experimentation. You can drag any commands you'd like inside the for loop block. These commands will be executed over and over for however many times you specify in the loop. When you run the loop, notice the app lab highlights each line as it executes. Now, why does the for loop block highlight after each iteration of the loop? That's because the for loop needs to check its counter every time to see if it should stop or run the commands inside the loop one more time. Well, that's not terribly exciting, but it's because we're not really using the computing power that looping gives us. Instead of looping this piece of code 4 times, let's loop it, I don't know, 200 times and see what happens. Now that's more interesting. One thing to note about loops is that your code will still execute from top to bottom as before. You can put lines of code before the loop if you need to get something set up before the loop starts. Likewise, after the loop is done executing, it will pick up on the line right after the loop. For example, if you want to move the turtle before drawing this figure, I could use a move to command before the loop. And if I want to draw a red dot to see where the turtle ends up, I could add lines after the loop. You will use the same top-down design in many of your projects. These problem-solving techniques will help you identify where loops belong in your code. You still might want to write a function to do a small part of your program, and then write a loop to call that function. Take, for example, the problem of trying to draw this. You might recognize that this is just a bunch of squares, each one rotated slightly before being drawn. Previously, we would have had to make a function to draw a square. To get the 10 rotating squares, we would have had to call this function 10 times, turning a little each time after we called the function. This would have involved a lot of copying and pasting. This code works, it does, but it's very repetitive. Let's just see if we can simplify our code with a loop. We already have a working function that does a piece of the problem once. We can easily stick the function call into a loop to do it multiple times. Clarity and readability are important considerations when programming. As we can see, this code is now much more readable. It's obvious just from looking at the loop that the intent is to draw a square a bunch of times. Loops are a powerful programming construct that uses the computer's primary advantage over humans, that being their amazing speed. By repeating commands as many times as we wish, loops allow us to solve new problems at a scale that would be impossible without computers. There is still much to learn about the loop, but the concept is simple. Loops repeat commands as many times as we need. Now you know how to use a simple loop. You can use them in your programs and take advantage of your computer's power and speed.
So the video may have looked familiar from last semester for those of you again who did the under the sea scene, which for who was in. All right, go ahead and we're starting again. Let's go and leave the phones away as they were supposed to be away. Thank you. So, who wasn't in my class last semester? Did y'all get to functions at all? The green blocks? You never talked about functions the entire semester. Okay. There's this thing called functions, and it's like one of the most important things in programming, and you didn't get to it an entire semester. That's not good. All right, so yeah. Those of you who were not in my class last semester, you should be able to, and I'd like, well, I'll put some links up there for you to get to because they are important. that it's going to be sort of on you to go back and do it. But while you're doing this, you can go to the lesson 1, the only bubble, excuse me, the lesson 5, current unit, lesson 5. The only bubble is a check for understanding, which we actually did. It was a similar one from last semester, like I said, where we know how functions work. Okay, a set of code that can be called, it's the play in the playbook, and that is, what am I doing? Spring 24. The oh no, we didn't do that. That's right. And then loops that we just talked about, where it's the exact same thing as many times as you want. Why would you use one versus the other? All in. I don't really. Oh wait, do I already have that? Never mind. What am I doing? All right. So, like I said, those of you who were not in my class last semester, it is absolutely in your best interest to at least go back to Unit 4 and finish it. I'm pretty sure you made it a little bit into Unit 4, but functions are everything. I'm super disappointed you didn't make it there. But here we are. So, okay. So when would you do one versus the other? Well, think about what they do and their slight differences. And their loops are doing the exact same thing over and over again. They will use a variable, usually I, as a counting loop. So you can do something to every item of something else, like to a list, which that's traversals. We haven't done that yet. But the function will receive parameters and can return something. So the function is a little more versatile because you can pretty much make it do anything or return anything, but it only occurs once. The loop does exactly the same thing, but as many times, and they almost always will be used together. It's just they are, different tools that seem similar, but I don't know, not really. All right, so let's go on to lesson 6. We have an app here, a very relatively simple app called the Coin Flipper app. And we can see what it does. Okay, so it takes in an integer, and you click on the coin, and it flips that many times and gives you the count of the results of head and tails. Okay, what information to take as input? The only thing the user does. How does that process that information? What is being repeated? And what information is the output? Well, based on the output, obviously the output, how is it processing the information? Well, we'll see here in a second, but we've seen before the use of random number, which is the only way you can do this, which go ahead to bubble 2. So the way that it's doing it is with random number 0 to 1. So random number 0, 1 will return either a 0 or a 1. In for real JavaScript, random number 0 to 1 will return a decimal between 0 and 1, for which you would need a like math.floor or math.round situation in order to get a 0 or a 1. And then the conditional, which both the loop and the conditional are blue blocks, which I guess they're related if you count like controlling where the program runs to. The conditional here, the if else, if a 0 is returned, heads goes up by 1. This variable heads, we have 2 variables used to keep track of heads and tails, the number that come through. And then total flips is just what the user puts in. But this one doesn't really need to be global because it's only used here, although it's not terrible to look at it, in order to see all the information that we're keeping track of. And this plus plus, I'm pretty sure I've shown you before, but plus plus is the same thing as heads gets whatever heads used to be plus 1. Okay. Why does it say missing semicolon? There we go. Okay, so this is redundant. Heads plus plus is the same as gets itself plus 1. I'll leave it as plus plus, even though it's probably the first time we've seen it. And it's actually strange that it is an orange block, because it's really more, the only time you'd ever really use it is as a variable. So I think it should be purple, but regardless. And okay, so it has the if else. Okay, if a 0 is returned, it counts as a heads. Otherwise, which in this case, there's only one other scenario, and that's a 1 is returned. We don't need a second conditional. We don't need to say if or else if flip double equals 1, have tails go up by 1. There's no need for that. The else, we have a binary situation where either a 0 or 1, the only other scenario is 1. Okay, and it doesn't matter if we check for 1 and give that to heads. Okay, or switch these. It doesn't matter if we check for 1 and then 1 goes to tails. It doesn't matter in this case because we're starting from random and it's either 0 or 1. Okay, this also sort of redundant is this local variable for flip. It is useful to gather up your random number into a variable, which is being wiped each time because of it's inside the function. It's useful if you're going to use it twice or more than once, however many times. But the only place we use flip is right here when we check to see its outcome, which means you kind of could get rid of it. This also should work as it's intended. Yeah. So if random number 0 to 1 double equals 1, which same thing, if random number 0 to 1 double equals 0, do this, otherwise do this. I do at this point agree with the use of a local variable just to organize things, but that is, so that's it. Okay, run the program, discuss the questions, partner, what happened, run the program, da, 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 da. When did you notice it take longer? Okay, so go ahead and throw some big numbers in there and see if you can get it to lag, I guess is the point. I think this is all running locally, which means that internet connection shouldn't affect things. Let's see what 10,000 does. That's probably going to be slow. Yeah, so 10,000 is a little laggy. I'm sure if you got to a certain point, it would say like error or technically cause it to freeze. Not literally, it's actually going through and doing it, but that was unnecessary. Let's refresh because there's no need. And we saw similar things like this when we were doing the digital scene thing where technically the loops, the program is supposed to run instantly or nearly, but when you're trying to tell it to do something 10,000 times, it does go slower. Loops, okay, the for loop is the only loop that we're using so far. Is that the only one we have? Yeah. Oh no, I mean we have while loops, but while loops require a little bit more foundation. You need to declare your own variable, your own counting variable, where for loop has a built-in counting variable. I is usually the name of the variable used for it, but it could be anything. Counter starts at 0, and while counter is less than total flips, which is the number we're getting, counter plus plus, that works fine. I is just the standard. It is probably short for index, although it's not super duper important. Okay, we have a loop. On which lines? Okay, we have a conditional. What does plus plus command seem to do? We have that. Okay, so like I said a second ago, you can make the counting variable anything. There are times in which J is useful and, well, having a second letter. Here, they're saying change all of the I's to J, which is what I just did with counter. But the reason why you would ever use J is for something called a nested loop, which if you had, let's say we had a table called, it's not even going to let me do it. What's a good table? I want a table with a lot of strings. Let's just see what this birds of the world, we've done that. Let's do primary color because I just need a list of strings. Get column 200 birds of the world. Choose color and call it colors. Okay, and so we have a list which is 100 or 98 birds long, even though it's called 100 birds of the world. And if we went through this list, this is actually a traversal where we want to do a loop, colors dot length number of times, and we'll get to the nested loop here in a second. We console log whatever is in our list called colors at the index that we're counting, at index I. Okay, and if we run this, can see it in a second. We're not dealing with the coins anymore. I'm just using the space. So here we are console logging what is in that position. But if we have another loop, in a nested loop, we can look at something from each position. And so we can use index or variable j. J gets 0, while j is less than. Okay, I is going to each element in our list. I want to go to each letter in each element in the list. So I'm going to do whatever one we're looking at, colors index I dot length. That's going to be the length of each word that we go to. And for each one, I want to console log what's in position I, index J. Okay. So I don't expect you to take away from this or take much away from this, but a nested loop uses both letters or both variables. And now if we console log what's in each position of the list at each position at that string, we should get every letter from the list printed out. Yeah. So, oh no, wait, index I. Oh, I forgot to change this to J. That is a common mistake when doing nested loops, is forgetting to do to change all the things. And there we go. We've printed out. Anyway, the idea is you can have your nested loops allow you to do sort of a two-dimensional situation, which is not what we're doing here. All they asked was if you could change the letters to J, which is the last part from bubble 2. Okay, go to bubble 3. And, well, that's weird. Wonder why it's like that. All right, so we have an app here that, let's see if it runs. Do they get it? Shoot. I hate when they give you a completed app and not let us actually do it. Okay, run the program, watch the code run. Okay, so what's happening here is too clever by half. The way they are using the counting app to define or to fill in the element that they want to set a property of is, it's super clever given the context of working in AppLab, but it's kind of useless outside of AppLab. They've named these text areas, text 0 through 4, and they are using the counting variable in each loop to make that element ID. Text plus 0 makes text 0. Text plus 1 is text 1. And so each time they're setting the property of these elements. And, you know, I'm never hesitant to share my disagreements with the way they teach things. Like I said, this is too clever and useless outside of this situation that, like, giving you, I don't know. Anyway, the app itself is doing the different, based on the different inputs, it is setting the text to each of those things from the user's input. All right, and let's see here what happens. We have font size slider. We have font color. Okay, on event, font color dropdown changes. We're setting the text color of every element to the get text. And here they are using the get text command directly as a parameter. Oops. A parameter for set property rather than, you know, where we, user color, and we put that there. and we set the text color to user color. Okay, so this is the way we normally would have done it. It's a little bit more wordy, but because we're only using that get text one place, it's fine to do that as the final parameter. And then random phrase, that's calling on this list up here, phrases. That is a list. You know it's a list because it starts with a square bracket. And inside the list, separated by commas, are the different elements, each element being a string. Okay, this list called phrases is made up of 4 strings, and they are complete, I don't know, sentences or phrases. But they are all single strings. Usually we've just used strings as a single word, but here a string is any stretch of characters, you know, taken literally. So the random phrase is just like we've done before, where we've picked a word at random or string at random from a list. We get a random, this variable is actually picking out the element. In the past, we've done var, var like rand index, var rand index, and give that a random number. And then from random phrases, we pick our random phrases is a new variable where we go to our phrases list at index rand index. Okay, this is the way we probably would have done it before. First picking a random number and then getting the thing from the list at that random number, where we could just get the thing from the list at a random number. Okay, anything that's a number can go inside of this space where it's looking for a valid index in this list phrases. So we can put in a hard-coded number, like actually put in the position that we want, or I don't know, there's lots of things. A return function that becomes a number. Here we are just using the random number generator, a random number block, as you know, directly into the index, and saves a whole line of code. And did I break it? Warning line 6, set property. Oh yeah, that's the thing from before. And what else do we have? So we have random and random. Let's add a feature. Find different loops. Find for loops. We did that. Take a look at the names. Design mode. What happens if you change the text box ID names? It's not going to work if you call them text box 0 because we're already naming them. Text. I don't really get the point of making that work. Okay, what happens if you change the Boolean expression while I is less than 5? Okay, well, this is just telling you how many times to do the loop. So I starts at 0. It stops, or it does it so long as I is less than 5. So the first time through I is 0. It does a thing to text 0, goes through the loop again, checks to see if our counting variable is less than 5. Well, after it adds 1, it's 1, checks to see if it's less than 5, goes back around, does something to text 1, adds 1 to it, goes back around and checks. If we only did it 4, while less than 4, it would never do the update to the last one. Okay, what I want to add to this is the ability to make sure that when you click random phrase, you never get the previous one, which we need, which you can see here, we only have 4 items in the list. There's a 1 in 4 chance that you click on it and it doesn't change. Is it 1 in 4 or 1 in 3? Yeah, 1 in 4 chance that it doesn't work or it doesn't change. What we need to do in order to make that happen is to keep track of what the previous one was. Now, we don't need to keep track of the previous phrase. We only need to keep track of the index used. And we need to make sure that whichever one we choose, whichever index we choose as the random one, we don't choose again. So if we're trying to keep track of something more than just within this, it needs to be a global variable. Because if we make it a local variable like var previous index gets whatever, it will get wiped every time through. So we need some sort of permanence. So go ahead, we are doing this. Let's make a variable called previous index or prev index, and we can start it at 0 just because we know there's something at index 0, and if there's ever not something at index 0, you know it's an empty list. We want it to be a number, it's fine. Okay, so actually, so the way we're going to do this is to check to make sure we're going to pick a number at random and make sure it is not the previous index. The problem is if this first random chooses the first element, it's going to see that the previous was 0 and it won't work. So I'm going to do something weird where we start this index, this variable at -1 to make sure that the first time through, it doesn't count a random, if that random number thing pulls out a 0, it won't count it as a repeat. Because our goal is to make sure we choose a random number that isn't the one we chose before. If we do, we need to pick another random number. So we're actually going to use a while loop. So our goal is here to pick a random number. So let's, we actually do need a rand index. And our rand index is going to pick our random number. And so we'll just call it rand index. And rand index is going to pick our random number. And our random phrase is going to be this rand index. But we need some code in between to double check and make sure rand index is not the one we made before. If it is, we need more randomness till we find one that isn't the one before. And once we do, we can go forward with that, but then also setting previous index to that new one. So the next time through, it takes care of it. So we're picking a random number that corresponds, and we need a while loop. Okay, while rand index is the same as previous index, we need to give rand number we need to update rand index, update rand index with another random number. Yeah. What happened to them?
Oh, wait, the one.
Oh, here you go. So while rand index is the same as previous index, we need to do more rand index. And our rand index is going to be the same range between 0 and phrases.length. What is the word? Phrases.length -1. So we're picking a new random number to make sure that it's not the same. And so if we pick a random index that's the same as previous index, well, we'll pick a random index every time we click the randomize button. If it happens to be the same as previous index, we are going to give it another random number, give rand index a random number, and it will check again, where if it picks whatever it was previously, it will run another random number. It will run until this is false. That is how a while loop works. And once it is false, we can continue. But first, we need to update previous index. prev index will get that random index that was different than the one before. Rand index, previous index gets rand index. So the next time we go through, it's checking what we got this time. Next time, it will check what we got this time. And I think this will work. If it does work, we should never get a duplicated phrase. In fact, we can maximize this testing by taking out two of the elements. If I comment these two, our list is only 2 elements long, which means that if this didn't work, we would get a lot of duplicates. Random phrase, random phrase. So there we go. Every time through, we get a new one. We are double checking that our previous one is not the same. And I think that is it for this. There is a check for understanding. I can't remember if this is a short answer situation or not. Yeah. Okay. So think back to the font tester app, which is the one we just did, specifically referring to the way that they did a loop to address every element, every design element, to create to concat the counting variable with the word text to make the name of the design element so that they could set the property of each element. That's the part they're talking about. The part that I said was too clever and irrelevant outside of this context. But clever nonetheless. I don't want to, disparage it too much. Okay, so can you think of think of an example of another app or feature of an app that which would use loop to control different elements of the screen? Okay, certainly do your best on that one. And that is going to be it for today.